Hello, welcome back, guys. Again, uh, today we will discuss this question. Just a minute, I need to see, see something. See such a way I have to start here, right? Here, you see input. So for uh, see input, see input. Okay. All right. So welcome back, guys. Again, right? Uh, Today we will discuss a problem which is very interesting problem called the minimum number of k consecutive bit flips, right? It's in a hard category of LeetCode, right? So this problem says that you are given a binary array called nums, right? And one you are given an integer k, right? So there is a binary array called nums, and there is an integer you have given is k, right? You have two things given. Now come here and you say what it is saying. Look, a k-bit flip is what is a k? It is defining the k-bit flip, right? It is like choosing a sub-array of length k, right, from nums. So we have to choose a sub-array of length k, which is what is the k? K is given. This is given integer, right, from nums, and simultaneously changing every 0 into sub-array to 1 and every 1 to sub-array to 0 means k-bit flips means we have to select a sub-array of length k and we have to flip the characters in that sub-array, right? And return the minimum number of k-bit flips required so that there is no 0 in the array. So we have to make the array all 1 by performing this operation again and again, right? So we have to find the minimum number of times we have to flip this. If we cannot do that, then we will return 1. A survey is continuous part of the array. Okay. So let's take this example. I think because it's just different, we can take this example, right? Here, what happened? Zero 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 1010 no 000 nums is like this. What? Right? So we have this nums here now. Nums is equal to 000. What is other? 10110, right? 10110. And what is k given? Uh, K is given as 3. Okay. All right. Now, guys, Okay. All right. Binary string. Right. Here it is. I'm just okay. So this is so we have to make the flips to make it one. So as a brute force, so every zero I have to make one, right? So whenever I encounter zero, I will try to make it one, right? So okay, this is one case. Other case it is like whenever go I go from like okay, I don't see any one till key length, so I don't see it's all zero, right? So I will make it one, right? Now this array becomes this 1 1 1 1 0 uh, 1 1 0, right? Then I went ahead. Now again I encounter this 1 0 here, right? So when I am encountering this 1 0 and 0 again, then I will again try to make this flip. So this will become 1 0 0 and 0. It will remain 0 right here. In this array uh, here and till then again I found 0. Then I will make this one. If I am able to. Okay, so one thing I have to address, guys. It's very important, right? Uh, this here you can see if I do this is 0 1, right? If I am making this here, right, 1 0, and then again I'm making this 1 0, right? Or I can do this this 0 1, like okay, let me do this thing. Let me explain you this thing. This is very important, right? This is very important here that let's say I have this 1 1 0 1 1 0. This is a array, right? If I flip from here, right, what it will give me? 1 1 uh, 1 0 0 0. But then I flip from here, this side, right? What it will give me? 1 1 1 1 1 1, right? Right, but if I would have flipped it from here, right? Here, I flipped it here first. 1 0 0 0 1 1. Then I flipped it which one? This one, right? Then I flipped it to this one. Then it will become 1 1 1 1 1 1. So again I am getting, so let's say this flip is A, this flip is B, right? So if I perform A before B or I perform B before A, right? Order does not matter here, right? So if order is not doesn't matter here, so here we can say recursion is not useful, all right? Because like if order matters, right, then we can if we perform this first, this is one branch, and we perform this first, this is other branch. So this will make out the two branches there, right? But order is does not matter, so recursion will not work here, right, guys? Okay, and this is our brute force. Like whenever I see 0, I will try to flip the next characters, right? So let's say this is I have n minus k plus 1. Uh, subarrays, right? And n minus 1 times IoT flip. So n minus 1 into n minus k plus 1 is the worst case order of time complexity, right, guys? So this will be order of n square, like approximately, right? This is order of n square time complexity. If I try to solve solve by this, then I can do that. If I write a code, right? Okay. So int n is equal to 0 and to count is equal to 0 here, right? Okay. So what I will do is for int I is equal to 0, I less than n, I plus plus. Then after that, what I will do is if nums of uh, I is equal to 0, right? Then what I will do is for int j is equal to I, right? J is less than I plus k, right? Okay, one more thing. If like I plus k, right, is greater than n, right? Then in that case, I cannot uh, perform the sub operation, right? Then I have to return one in that case, right? This is one case. Okay. Else, what I will do is for into j is equal to I, j is less than I plus k, j plus plus. This is our window, right? And what I will do is if nums of I, so okay, nums of I, no, j, right, is equal to nums of j is equal to if it is 1, right, then it will make it 0, right? If it is 1, then it will make it 0, else it will make it 1 if it is 0, right? So this is our scene, and then what I will do is and I here I can count, flip the count also, right? Count plus plus, and at the end I can return the count, like here. I didn't count, and let's try to run this. What's it, please? Okay, K is capital U, K should be small here, okay. Whatever. Okay, it's all wrong answers. Why? Output 0, expected minus 1. Okay, everything is 0, guys. Why it is so count 0 for if nums I is equal to 0. Okay, it's integer, right? Yeah. If it is 0, then no, it should be J. J is less than I equal to K, and J plus plus count. I think it should have worked. Count is not increasing. Okay, it's none only. Okay, right. Oh, n is equal to nums dot size. Wow, what are we doing here, guys? So here it's account plus plus. So if I cannot, all right. So you can see it's passing the results. Let's try to submit this here. What happens? What is the 10 complexity and all, right? So you see here, guys, it is giving us time limit exceeded, right? For like at least just 3 cases, right? So what we can do, we have to think about another solution about this problem, right? So let's take this just this example only, right? And take it here. Oh, okay, right. Take this here. Now nums is this, right? So we have a concept called a difference array. Okay. What is this called? Difference array concept. This is called like, okay, let's assume there is a train, right? Let's say you you drive a bus, right? Drive a bus. There is some stops. Stop one, stop two, stop three, stop four, stop five, stop six, stop seven, stop eight. There are 8 stops. And you see, for example, let's take example and assume that there are like uh, like 10 passengers, right? From stop 2 to stop 6, right? So what you will do, you have a register and you write, okay, at stop 2 there were 10, there were 10, there were 10, there were 10, there were 10 passengers, right? If your like manager asks you, okay, how many passengers were at stop 4, right? You will say, you will look into your like diary and it's tell you, oh, it was 10. Let's say you have capacity of like you have like 1000 stops, right? Will and from stop 4 to stop 1000, then again like they plus 2. Okay, so whenever a passenger get on the bus or like board on the bus, right, you have to write like from this passenger this. So it's very exhausting. So instead of that, what you can do is like, okay, uh, 10 passengers from here, and they will drop at 10. So I will do -10, right? Then what I can do is two passengers from here, S4, 2, and they go with let's say S8 -2, right? And if anyone asks, okay, how many passengers were at S5 and how many passengers were at S9 and S8, right? This is your queries. So how you prefer? How you will calculate those? Okay, you go from station 1, all were 0, right? This was 0 and all were 0, right here. 0, 0. No, if this was 10, right? 0, 10. This was all 0. This was 2, and this was 0 here. This was also 0, 0. And here you say -2, and all other are zeros, right? Let Okay, wait. Let's keep it clean again, right? Keep it clean. 2 -2. So what is the fun? What you should write, right? What you should write is you have these passengers. You have S0. You have 10 here. All other are 0. You have S4, S2, right? S5 is 0. S6 is -10. 7 is 0. The 8 is -2, and all other are 0, right? So if someone asks you, okay, how many passengers are at 5, S5, and here, and how many passengers are S8 here, and S9, how many passengers are here? So what you will do, you traverse the array from left to right, and with prefix sum, okay, prefix sum. So here it is 0, 10, 10, 12 here, 12, then 2 here, 2 here, 0 here, 0 here, 0. You know, at this it was right. You can perform that. Okay. According to that, what we can do, guys, right? What I can do is here. Now you see, this is our array, right? This is our array. We have to make it all one, right? So what I can do, whenever I see a 0, right? So I need to make it 1, right? Because if I leave it here, if I leave it here and go ahead, then I will not, if I have to perform this in order of 1, I will not come back to make it 1, right? I have to make the flip. So you see, when I make the flip here, this will become 1. Then if I make flip again, this will become 0. So if I'm making even number of time flips, there is no change. If I am making odd number of times flips, so till where the effect is of this flip, I have to remember this, right? One thing is this, because let's say the example was this 0 and 1 0, 1 0 1 1 0. If I make this flip, this will become 1 0, right? 1 1 0 1 1 1. So effect of this flip is still here, right? This was already 1. Now this will become this has been become like, now this has become 0, right? Now I have, if I traverse this, I have to make the flip here, like, right? I have to make the flip, and this is again change the array, right? So this will 1 0 0 1 1, no, it's 0 1 1 1. You see, this was 0 before, this was 0 again. Why? Because it take the effect of 2 flips, even no change. So if this index is taking the effect of 2 flips, and I remember that if the effect of this flip is here or not, right? At this index is there or not. So if the flip, wait a minute. So here you see one effect is from here to here, and other effect is from uh, here to here. No, we can see like this. One effect is from here to here, other effect is from here to here. Right? So this element is taking effect of two. This element is taking two flips, right? So if I know that this element is flipped, if I remember that this element is flipped, so I also know that the index I is flipped, then all the elements of I plus no, k minus 1 also flipped, right? I know that automatically if I is flipped. So I have to remember that if index I is flipped or not. If it is flipped, then if it is flipped, then this like number of flips, if it is even, right? If this element is flipped, if this element is flipped, then this element, uh, how many times is it is flipped? This is also a like if it is flipped one time, right? This element is flipped one time, or let's say this element is flipped one time, then uh, right. So this element is flipped one time. Let's so if this is flipped, then I know that this element also flipped because it is in the range of I plus k minus 1, right? And if this is flipped like if it is in effect of two flips, right? If it is in effect of two flips, then it will not change the state, right? If it is was 1, then it will remain 1. If it was 0, then we will consider it after, right? And one more thing, I think, guys, we have to consider is the number of active flips, right? Number of active flips. So when we reach this index, right? So one flip was here, one flip was here. So he this flip here also and here also, right? So we have to consider that also. Now, how many effect? If it is like even, right? Even flip, then it will zero. It will remain zero, right? Because it is zero. Then we have to make the flip. If it was odd, flips equal to zero. Okay. What I will do is if nums I right, if nums I whatever I am, it is like active flips are zero, right? So if it is like active flips modulo 2, if it is like even number of flips, because it is zero, and if our nums I also zero, then what I will do, I will increase the active flips count, right? Active flips plus plus, and also count plus plus because I have just performed the count, right? And next thing I will do is